Yeah, very good morning, all. Today we will see about the advanced Python programming experiment number one. The experiment number one is to implement the Python object oriented programming concepts and such as classes. Okay, next Python objects, next initialization method, next class and instance variables, and inheritance, next polymorphism. These are the main topics which are in the experiment number one. Okay, so we will and encapsulation also, Python encapsulation. Okay, so and abstraction. So all these concepts will cover mostly for experiment number one and experiment number two in your syllabus. Okay, so now we will see what it, in brief, how to learn these things. So OOP stands for object oriented programming. Object oriented programming is a fundamental concept in Python, okay, which empowers the developers to build modular, maintainable, and scalable applications. Object oriented programs is a way of organizing code that uses objects and classes to represent real world entities and their behavior. In object oriented programs, object has attributes, things that has specific attributes means which are the specific things that has data and can perform certain actions using methods. Okay, so the contents of this class is the class in the Python, objects in Python, polymorphism in Python, encapsulation in Python, inheritance in Python, and data abstraction in Python. Okay, next. So we will see what is a class. A class is a collection of objects, simply. A class is a collection of objects. Classes are blueprints for creating objects. Okay, a class defines a set of attributes and methods that the created objects can have. Some points on the Python class are, so classes are created by keyword class. We need to use the keyword that such as class. Attributes are the variables that belongs to a class. Next, attributes are always public and can be accessible using the dot operator. For example, if uh, if a attribute my class is there, okay, my class dot attribute. So whatever the attribute that is my attribute is there, that is in the my class. So it can be accessible by the dot symbol. So if we see the one program, then it can be better understandable. See, this example generally will create the class which is named as dog. Okay, so if we are using a class, if we are using a class, then it must be followed by some name for it. For example, class dog. We can use class cat like that. So, and species in the class dog, species is defined as canine class attribute, which is a canine class attribute. And we can initialize this class attributes such as with some parameters like self, name, age. So self dot name is equal to name, self dot age is equal to age. These are instance attributes. So coming to the explanation, class is a dog. Okay, class space dog column. Species is a class attribute shared by all instances of class. So now, and initialization method initializes the name and age attributes when a new object is created. Clear? Now, what about Python objects? An object is an instance of a class. Object is an instance of a class. It represents a specific implementation of the class and holds its down data. An object consisting of state, it is represented by attributes as well as reflects the properties of an object. And behavior, behavior is represented by methods of an object and reflects the response of an object to other objects. Identity, It gives a unique name to an object and enables one object to interact with the other objects. So, in brief, an object is consisting of three parameters: state, behavior, and identity. Okay. So, how to create this object? Consider the same example previously. Whatever the example we had seen in the previous for creating creation of a class dogs, the same example is recalled. Okay. It involves instantaneing a class to create a new instance of that class. This process is also referred to as object instantiation. Okay. So consider the define a class space dog species, define an attribute, and initialize the species instances name age with some parameters. Now you call the dog one. You call create object of the you call you can create one object like dog one. Dog one is equal to capital dog of buddy comma 3. So here buddy is name and 3 is the age. Now print dog1 dot name. See how to recall this particular instance. Dog1, whatever this dog1 dot name. Similarly, print dog1 dot species. So automatically these two will be giving you the dog1 name, that is name of the dog1 parameter is buddy and dog1 species is canine. Okay. Next, self parameter. So self parameter is a reference to the current instance of the class. It allows us to access the attributes and methods of the object. For example, consider the same example again. Class space dog. You are defining a dog with the attribute as species and initialization parameters as name comma age. Okay. So here self is nothing but uh, initialization parameter. Whatever variable you are defining, you are assigning for an object dog, so the self will belong to that one. Self dot name is equal to name, self dot age is equal to age. Okay, initialization is over. Next, take the variables dog1 and dog2. Dog1 is equal to capital dog buddy comma 3 and dog2 is equal to dog charlie comma 5. So you had created two objects. You had created two objects. Now, how to recall that parameters? That is the thing. Print dog1 dot name, dog1 dot name, dog1 dot age, dog1 dot species. Similarly, print dog2 dot name, dog2 dot age, dog2 dot species. Similarly, these two print commands will access the instance and class attributes, while print dog.species will access only class attribute directly. Okay, so the output is the first print command output is buddy, its age is 3, and its species name is canine. Similarly, whereas second print command also will give you the Charlie, its age is 5, and it belongs to canine. But third print option, print dog comma species, it will access attribute directly, which is an attribute. Canine is an attribute. Okay. So next, what about this init command, init initialization method? So which is represented by double underscore init double underscore method. So consider the same example. Define a class dog and define init command self name comma age. Self dot name is equal to name and self dot age is equal to age. These two are initializing. Initially you are giving some values. Now you can create one object. Dog one is equal to capital dog buddy comma 3. Print dog one dot name. It will give directly buddy. Okay. So init is a special method used for initialization. Okay, self dot name and self dot age, these are the instance attributes initialized in the constructor. So what is the difference between class and instance variables? In Python, variables defined in a class can be either class variables or instance variables, and understanding the distinction between them is crucial for object-oriented programming. Class variables. These are the variables that are shared across all instances of a class. Class variable is shared across all instances of a class. It is defined at the class level outside any methods. All objects of the class share the same value for a class variables unless explicitly overridden in an object. If you define, if you overwrite that in the object, then it will be different. Whereas instance variables, variables that are unique to each instance of a class, okay, these are defined within the init method or instance methods. Each object maintains its own copy of instance variables independent of other objects. See, in this program, the usage of this particular class variables and instance variables is there. Consider again same program. Class, define a class, class variable, species attribute is defining, the instances you are defining with the help of init command. Okay, objects, dog1 is an object, dog2 is an object with these parameters. Access class and instance variables. How to access? So print dog1 dot species, then it will give the canine. Print dog1 dot name, dog1 is buddy, its name is buddy, so it will give this one. Similarly, if you want to modify instance variable, so you can modify. For example, dog1 dot name is equal to, you had specified capital max, capital max, max. So in that case, if you take the print command, print of dog1 dot name, which will return max. Similarly, if you want to modify class variable, yes, you can vary. For example, dog dot spaces, you can define it as a, or you can initialize or overwrite as a feline. Then print dog1 dot species is equal to feline, and print dog2 dot species is equal to feline. In this case, if you changing the class variable, whatever objects you had defined, all that object will be directly accessible to the class variable. Clear? Next, Python inheritance. You know inheritance? Inheritance is nothing but it allows a child to acquire the properties of the parent. Similarly, inheritance allows a class to acquire properties and methods of another class. It supports hierarchical classification and promotes code reuse. So in Python, we are having a single inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance, and hybrid inheritance. In the single inheritance, a child class inherits from the single parent class. In multiple inheritance, a child class inherits from more than one parent class. Okay? Multi-level inheritance, child class inherits from parent class, which in turn inherit from another class, like our fathers and their fathers. We are inheriting some properties from our fathers or our parents, but our parents inherited some properties from their parents, that is our grandparents. Okay, that is multi-level. Hierarchical inheritance, multiple child classes inherit from a single parent class. For example, this can be better explained by the family structure. Okay, so for example, if we are having a one family head, for that family head, the it may be, he may have daughters and he may have sons. Okay, and uh, he will have some relations also. So this sons, these sons and daughters will be having a some type of another their children, and the sons and daughters is having a their unique children. So all those children are related to somewhere else. Okay, but all these children of the sons and daughters are inherited some type of properties from this family head. Okay, so this is known as a hierarchical inheritance. Okay, so while parents coming to the parents, the daughters, if the family head is having a daughters, the daughters will get married to some other families, and that family head is different. That family head is different. So he whoever the children who are for this who are born to these families which are from different heads will have some properties belonging to first head as well as second head. Okay, first head as well as second head. So that is known as a hierarchical inheritance. In hybrid inheritance, a hybrid inheritance is nothing but combination of one or two more of types of inheritance. See, this program will explain you about the inheritance. Consider same example. Define a class dog, initialize it with the name. Okay, uh, define display name. Okay, self, print f dog's name comma self name. Class, you can define class as a labrador. In that you are defining sound. Okay, so print labrador woofs. Next, multi-level inheritance. Class guide dog, if you define a class as guide dog is labrador. Okay, labrador is you have inherited from this one, and you are defining guide as self. So print self dot name guides the way. In this one, what is the output? The output is self. Here labrador you are defining. The labrador will have properties from this particular previous case. Just a minute. Hello. Mm, mm. You come to me. You come to me with a letter. Yeah, in the break time you come. Okay. Thank you. See, I am in the class now. Sorry for the disturbance. Okay. Coming to this one, you are defining one more class as a guide dog. The guide dog will take the inheritance from this particular class Labrador. Okay. So it is Labrador woofs. So in this, you are defining guide self, printf self dot name, here self dot name guides the way. Labrador, here Labrador guides the way. That is the this one will take the parameter from this particular one. Next, multiple inheritance. Class friendly. You are defining some greet self printf friendly. Class golden retriever dog comma friendly. So here what happens this command, it is you are defining a class with multiple inheritance. The parameters are passed to this one from this particular dog as well as and this friendly. Both classes it will take parameters. So print golden retriever barks. So these are the some example uses. Retriever is equal to golden retriever Charlie, retriever dot display name. So these are the examples. Next, what is polymorphism? Polymorphism allows methods to have same name but behave differently based on the object's context. It can be achieved through method overriding or overloading. Okay, so this the polymorphism can be achieved through method overriding or overloading. So types of polymorphism. There are two types of polymorphism: compile type polymorphism, runtime polymorphism. Okay. So compile type polymorphism. This type of polymorphism is determined during the compilation of the program. It allows methods or operators with the same name to behave differently based on their input parameters or usage. It is commonly referred to as a method or operator overloading. Runtime polymorphism. This type of polymorphism is determined during the execution of a program. First one is during the compilation of a program. This second one is during the execution of a program. It occurs when a subclass provides a specific implementation for a method already defined in its parent class, commonly known as method overriding. Okay, so there are two cases: operator overriding and method overriding. Clear? Operator overloading is known as it can be achieved in a compile time polymorphism. Method overriding can be achieved in a runtime polymorphism. See, the same example we can see again. Parent class is defined as a dog, okay, and runtime polymorphism class Labrador dog. So you are defining a class as Labrador, which is overwriting the dog. So next class Beagle, which will be overriding the parent class dog. Okay, compile these two are runtime, whereas compile time polymorphisms can be achieved by class calculator define add self comma a comma b is equal to 0, c is equal to 0. So what you have done, you are defining class as a calculator as a class, define add. See this particular command add self comma a b c. So it will add these three things and return a plus b plus c. That is compile time polymorphism. Next, runtime polymorphism: dogs, dog, Labrador, beagle. Okay, dogs is equal to, we are taking three things, three classes: dog, Labrador, beagle. These three classes are just defined as a class of dogs or dogs array. For dog in dogs, dog dot sound. So what it calls this dog sound, Labrador woofs, beagle barks. Okay. Similarly, compile type polymorphism. Call C is equal to calculator. Print calculate call C add 5 comma 10. It will take two arguments. Similarly, print call C dot add, which will take three arguments 5, 10, 15. Clear? So this is just an explanation about program. Next, Python encapsulation. Encapsulation is the bundling of data and methods within a class, restricting access to some components to control interactions. A class is an example of encapsulation as it encapsulates all the data, that is member functions, variables, etc. Okay, so next, methods, variables, class. Methods is, it will, class can contain methods as well as variables. So encapsulation is bundling of attributes and functions within a class, restricting access to some components to control interactions. Next, types of encapsulation. So in the types of encapsulation, we are having three types: public members. The public members can be accessible from anywhere. Protected members accessible within the class and its subclasses. private members which can be accessible only within the class. Okay, so this particular program will give you the technique of encapsulation. For example, here class dog, it is a public class. Okay, so whatever this is initialization, initialize with the class with the name, breed, age. Okay, so next public method, define get info self, return f name self dot name, breed, age, etc. Getter and setter for private attribute. Okay, this define get age. This get age is to be taken from this one, return self age. Similarly, set age is taken from this one. So this is public method, whereas private attribute, the private attribute is nothing but which will be related to this one only. Okay, whatever you are calling here, they will be, the attributes will be passed from this particular class self only. Okay, they are not belonging to this public class. So these are the examples. For example, dog is equal to dog buddy comma labrador comma 3. It is a public member. Similarly, if you are want to access the protected number, print dog dot name, that is the there. And next, similarly, if you take a uh, accessing private member using getter, so you can use this type of command, print dog dot bet underscore age bracket close. See, in this one, the protected members used with a single underscore, such as underscore breed, access is discouraged but allowed in subclasses. Private members used with double underscore, such as double underscore age, which access requires getter and setter methods. Next, data abstraction. Abstraction hides the internal implementation details while exposing only necessary functionality. It helps focus on what to do rather than how to do. Okay, types of abstraction, partial abstraction and full abstraction. See, coming to the discussion of this abstraction, so paper, technical paper, any technical paper is provided with compulsorily some type of abstract. Abstract is simply an paragraph size which will contain all the details of out, outline of the whatever work you had done in the paper. So the same can be compared to here also, the data abstraction and types of abstraction. Clear? Say this example will be uh, embedding the abstraction from ABC import capital ABC abstract method. Okay, so capital ABC, you are defining it as a class dog. Okay, and define display name class Labrador, class Beagle, like that. So you are all defining. Now dogs, you are creating as an array for a dog. In dogs, this dog dot display underscore name, it will calls the concrete method, and dog dot sound, it will be, if here dog dot display name means what it will display, lab dog's name. One is Labrador, second one is Beagle. Dog dot sound will calling woof, bark, like that. Okay, so this is a simple thing which I had used for your explanation purpose. If you are having any comments or you are having any doubts or clarifications, you can come and discuss with me. And for that, you can use my email ID or mobile number. Okay. So email ID is chiranjeevi210 at gmail.com, and mobile contact is 94402187797. Thank you. Have a nice day.